All right, so let's talk about something interesting. So we're going to be talking about the backlog queue when you establish a TCP connection. So when you try to establish a TCP connection, what happens? You do a TCP handshake, right? Imagine that you are dealing with a server which is blocking, and at the same time you are establishing connections, right? So those connections definitely are not going to be served because those connections are blocked. So what happens to those connections? Either they get dropped or those connections get queued into the connection queue, which is also known as probably backlog as well. So in this video, we're going to be observing how the backlog queue changes based on the connections we're trying to establish. All right. So we have a very basic TCP server which handles one connection at a time and which basically receives a connection and then it sleeps for 10 seconds and then it sends acknowledgement or response to that connection and it closes the connection, right? And we have a simple client which basically spins up 10 worker threads, and then each of those worker threads are making a connection with the server. So what we want to observe is that here we have, let me just try this command again. So here we're basically observing the status of the backlog queue that is running um, to the socket that's binded to this port, this 8080 port. All right. So currently there is no socket binded to this port because I have not run the server. So if I run the server, we can see the status of the backlog queue. So this receive queue is basically the connection that's being received, the connection that was established but not handled, not accepted, but it's queued. The connection is established. The TCP handshake is established, but the connection was not being accepted by the server, and it's not being handled by the server. So if the connection is not being handled by the server, not being accepted by the server, but the connection is established, then the connection stays in this backlog queue. So what we are going to observe, what we expect to observe is that when we run our client, definitely there will be 10 TCP connections by the 10 worker threads. We expect to see a spike in this receive queue. And since the server is basically blocking for 10 seconds and then replying back to the connection, so we are expecting to observe that this receive queue will be changing within 10 seconds and it will decrease within 10 seconds, right? So let's go ahead and let's do the experiment. Okay, let me just okay yeah, we have made 10 connections and we can see here we're having nine connections in the queue because one connection is being handled already. You see now one connection is being handled and it is released. Another connection was taken from the queue and the receive queue decreased to 8. And in the same way, it's continuously decreasing as soon as we are getting response in the client, which is meaning the connection was being handled, the connection was being accepted from the queue, it was being handled, and then it responded back. All right. So the reason behind showing this, or the reason behind observing this, is that when you have a server that's probably like spinning up a limited amount of thread to avoid the unlimited memory usage, what happens in that case when all the threads are blocked? If all the threads that you have spinned up, you have pre-spawned those threads and you fixed a number of threads, you fixed a number of workers, your machine or your server will not spin up more threads than that. All right. What happens in this case? You cannot spin up infinite amount of threads. In that case, in a very high load, you may end up queuing those connections. And it depends on the backlog configuration that you are giving in your server. So yeah, now we see that we have all those connections being served, and we can see that the receive queue is now 0. We don't have anything else. All right. So yeah, That's it.